Hello, chemistry students. I've had a couple people ask about this homework, so I wanted to walk you through a little bit of it. In class, we worked on this unfamiliar problem. We balanced the reaction, and then we worked backward to say, okay, if this much CO2 was absorbed in this much water, the ocean, and we convert those kilograms all the way to moles, we divide moles of CO2 by the liters in the ocean, we could get a concentration of CO2 in the ocean. But the ocean's pH is what it asked for. So if we want that, we've got to convert concentration of CO2 in the ocean to concentration of H3O+. And for that, we need this chemical equation up here. So we did that. We got a concentration of H3O+, and that should say capital M right there. Oh my gosh, I forgot my units. How embarrassing. Convert that to scientific notation, and that's how we can get an estimate of the pH. So then the next question is giving people some trouble, but I want to be honest, I think you're overthinking a little bit. We had to delay the lab because we didn't have enough calcium carbonate. Okay, but we could have just made that calcium carbonate. We know how to make it. You mix sodium carbonate with calcium chloride, and that makes calcium carbonate. So if we wanted to make 4 grams per student of calcium carbonate, how much of these would we mix together? So that's the problem that I'm asking you to solve here. If I tell you I need 4 grams of this, can you work backward and figure out how much of each of these I need? If you really want to push yourself, you can also consider the fact that if you mix these two together dry, they won't make calcium carbonate, but if you mix them together in water, they do. So that would be a stretch, that would be like a sophisticated level, but all I'm asking you to do here, start with 4 grams of calcium carbonate, go grams to moles to moles to grams to figure out how many grams of each of these you're going to need. Okay, so that's what's going on in this problem. Now, on the inside, we've got some more problems, but these are very similar to the problems you did for practice. So once again, we've got 320 grams of this. Okay, we react it with 42 grams of this, and we want to know how much of this we're going to make. Okay. And it asks you how many liters it's going to produce. Okay, well that's a little weird, but remember, we know how many liters there are per mole of a gas. So what it's telling you here is that this is probably going to be a gas. Okay, so can we figure out if I have grams of this and grams of this, how many moles of this is going to be made? Absolutely. Or excuse me, of this is going to be made? Absolutely you can. And if you can figure out how many moles of this are going to be made, can you figure out how many liters it will make if it's a gas? Yes. And that was a little tricky, so that's why I'm making this video, just to help you walk through these. Let's look at the next one. We've got 7.4 moles of O2 gas, and that's being reacted with 1.5 liters of C3H8. Okay, so once again, we know there are 22.4 liters of gas in every mole of gas. Okay? And that goes back to our gas laws. Because gases, we can assume they're infinitely small, we know that at standard temperature and pressure, this is about how much space they'll take up. So if I've got this many moles of one gas being reacted with this many liters of another gas, well, we can go liters to moles, and we know how many moles we have of each. We want to know grams of CO2. Okay, so we can go liters to moles to grams. And then for this one, we already have moles, so we can just go moles to grams. And that will tell you, whichever one of those numbers is smaller, will tell you how many grams of CO2 can be made. Kind of the same way up here, we're going to figure out which one of these is going to run out first. One of these is going to be our limiting reactant. And it may have been a little while since you thought about limiting reactant, so you might need to move back, or turn back here, to remember your limiting reactant notes. Remember, limiting reactant is the first reactant to be completely consumed, and that will stop the reaction. So in our case, chocolate was our limiting reactant. We only were able to make 108 s'mores rather than 120 and 186. Chocolate's going to run out first, so no matter how much graham cracker or marshmallow we've got left, we're only going to be able to make 108 s'mores. Same thing. Oops, that was too far. There's our homework. It's the same thing in the stoichiometry homework. One of these is going to run out first. Whichever one runs out first is going to determine how much of the H2S we can make. Same thing down here. One of these is going to run out first, and that will determine how much CO2 we can make. All right, let's take a look over at this question. There are 8.432 liters of oxygen. Okay, well remember, we know how many liters there are per mole. And they're reacted with 0.3825 moles of this gas. Okay, how many grams of CO2 will be produced? This problem is very similar to this problem. Okay, so don't overthink it. We can do liters to moles. Okay, and we already have moles of this one. Once we've got moles of each of these, we can go moles to grams. And anytime we go moles to grams or grams to moles, we're going to use a molar mass. Okay, and if you're struggling on molar mass, remember we learned molar mass back here on page 86. Okay, and then finally this bottom question, if we've got 23 milliliters of 0.5 molar NaOH mixed with 15 milliliters of 1 molar HCl, what will the pH of the solution be? Ooh, that's tricky. This is an actual, unfamiliar, tricky question, but I want to give you some hints on this. You know that this is moles per liter, and milliliters tells you how much of that solution you have, so you can use that to figure out how many moles you have of NaOH. And you can also use that to figure out same process to figure out how many moles you have of HCl. Okay, and from there I want you to think about it. On this problem, I'd like to see you attempt it. If you get to the answer, congratulations, that's sophisticated. But if you can begin to attempt it and arrive at some reasonable answer, even if it's incorrect, that's great practice for our upcoming summative. So I hope this is helpful. I want to remind you as well, there is that chemistry Padlet where you have lots and lots of practice problems to help you practice your stoichiometry. You've also got practice problems here on 110. You also have an overview of stoichiometry here with s'mores, and you also have Mishrak and I and IAP. So I hope this helps. Really lean on that Padlet. If you're feeling stuck, watch a lot of videos. It'll help you understand what's going on there.